Okay, good afternoon. We are presenting a case study on the golfer's link. So we've divided this into three parts: the problem, the model, and the additional analysis. I'll be giving the introduction on the problem. Shifa will talk about the model, and BJ will talk about the additional analysis. So the golfer's link is a company which manufactures different types of golf clubs for every member of the family, for men, women, and juniors. And there are three manufacturing facilities located in Daytona, Memphis, and Tempe, which supply to the distribution centers located in Sacramento, Denver, and Pittsburgh. So our main problem is to maximize the profit considering the shipping costs and the production plan. So these are the revenues generated for each type of golf clubs for men, women, and juniors, which are $225, $195, and $165 respectively. So these are the three manufacturing plants and which distribute to these three locations, and all the manufacturing plants locate supply to all the three distribution centers. But there are two manufacturing plants, that is Memphis, which does not produce men's golf clubs, and Daytona, which does not produce juniors golf clubs. And there are different raw materials which are required for each type of golf clubs, so which is given here. So for example, for men's, we need 2.9 pounds of titanium, 4.5 pounds of aluminum, and 5.4 pounds of rock maple. And these are the total capacities which are available at the manufacturing plants at the different manufacturing plants. Okay.
Okay. Now I will talk about the model formulation. So if you want to build a model, first you need to know the decision variable. We set the distribution center equal X and the manufacturing plant equal Y, and we set club set type is Y. So this is for example, like SAM means numbers of men's club set shipping from Sacramento from Daytona. So object function, we need to get the maximum the net profit. So we just need to use the total revenue to minus the shipment cost. And if for the question 4, we also need to minus the penalty. So this is our object function. We watch the video. So doctrine said the penalty is minus is no matter how many orders you didn't match, you just need to consider the penalty is 10,000. Here is this is in our model, and how can I check switch to our model in Excel?
And the slide here. Okay.
Here. This is our model. I talk about the net field. Just use the total revenue to minus the shipment fee. The total revenue. Just use here the revenue of the men's, women's, and juniors, and times how many clubs that you produce. So here totally. And for the shipment is just use how many. Here from C7. This is a decision variable.
Click into the formula, it will highlight. So click into the sum product formula. Double click.
This way?
So it will highlight.
Okay.
The part that you are clicking sum product.
actually, you also can see from here. Yeah. And this is a shipment cost. The net field just use the total revenue minus the shipment cost. Okay. For the question 3, just the constraints just changed. For the question 4, we need to consider the penalty here. So if for this penalty determination, we found that the sum is 5, but like I said before, we just had to calculate its penalty is 10,000. Okay. This is our constraints. This is we use I to represent different constraints. 90% means in question 1 and question 2. 0% for the question 3, and 80% for the question 4. This is a constraint due to the distribution orders. This is a constraints because you need to consider how many material you have. Here, this is a constraints 3. Also, on the problem statement, we found that Daytona doesn't produce the junior club set, or this place didn't produce the men's club set. Okay. Last constraints about the, it can't be negative, and it should be integer, because we can't produce half club set. So this is our modeling building part. So next, BJ will introduce the analysis part.
Thank you. Nicely done. Does this work with, does it work with animations?
Ruby.
Okay. What's that? Oh. So what we said was, this is ultimately what Rick is looking for. He wants to maximize his profit. So what Rick wants to know, I'm assuming that I'm talking to you as if you are representatives of the Golfers Link. And really what you want to know is, can we make more money? And the answer is yes. Yes, you can. So these are 3 ways that we figured out that you can make more money. One is simple. And one of the pros of the first option is also that it's totally an internal control decision. It involves nobody else. It's just our willpower and interest in increasing our profits. And we can adjust our raw materials inventory levels and make an additional $181,000. The second one will possibly frustrate our distributors, because it would, in order for us to increase our profit by less than 50 grand, we would have to, we would be at a little over 50% for our juniors club sets for 2 of our distributors, 2 of the distribution centers. So they might be a little frustrated by that. Another analysis that we performed was to say, hey, well, what if we could change our contract and they would let us stock less than what our current contract states, which is 90%. So what if we could reduce that threshold? If we could reduce it to 50% or even 80%, probably the distributor would say, okay, well, we'll give you that, but we want something in return. And so something that they might say is, well, we'll charge you 10 grand every time you have less than 90%. So we just did a hypothetical scenario there. Again, you know, trying to get less than 90% and assuming a $10,000 penalty, that would totally require renegotiation of the contract. And I wasn't clear when the contract is coming due, so I don't even know if that's an option, but it's just something interesting to consider. So again, this is just a little more detail on the first analysis, that we can increase our net profit by approximately $181,000. And the way that we looked at that is we said, what are our constraints to resource availabilities currently? And you can see in Daytona, the top constraint is, it's the left-hand side of the constraint. The bottom is the right-hand side of the constraint. So for example, in Daytona, we used 5,999 pounds of aluminum, and we had 6,000 pounds. So that, and you can see that in Daytona we had additional materials of titanium and rock maple. So if we just increased our supply of aluminum, we could have made more golf sets and therefore make more money. And again, the same story in Memphis. In Tempe, you can see it's the rock maple that was we were bumping up against. So very simple. It's just for 1 month. But if we could just for that 1 month increase the supply by a little bit, we can significantly increase our profits. And then again, this is more detail about reducing the juniors club sets to approximately 50% level. The way that we ran this is we actually said, well, let's just go ahead and say that there's no minimum order at all. And when we ran the solver, the solution came back as showing that we would actually get 100% of the men's and women's golf sets, and 100% of juniors in Sacramento, but less in Denver and Pittsburgh. So tell me why. Why do you think that would be? The room is filled with silence. Yes, exactly. Thank you, Caleb. Yes, more profit in men's and women's. So that's why, of course, the model is going to say, well, let's throw 100% at men's and women's, and let's reduce juniors. And again, the last one is we can increase the net profit by 15 grand, but again, this requires negotiations with our distributor, or just deciding that we're going to make them angry, which is probably not a good idea. I wouldn't recommend it anyway. So again, for your consideration, who can adjust the raw material inventories levels? Of course, the Golfers Link. And then increasing the raw materials meets our minimum order level. We don't have to worry about making our distributors angry, so it has the added benefit. And then I don't know the answer to this question, whether or not we can even opt to ship less than our minimum order. What will happen to us? What will the distributor do? Has it ever happened in the Golfers Link history before? So would we be penalized now? Is there something in our contract that I didn't see? But it is interesting to consider for the next contract, particularly when we think about the juniors golf club sets. If we're talking about a 50% minimum where we can make a lot more money on the men's and women's, if we could keep it at 50%, that might be worth to consider next time the contract is up for negotiation. So, who's on what? Who's going to do what? Any questions? Further analysis you would like from us? I knew you were going to have something. The pros and cons of the last one?
Question asked was, if you were to reduce it to 80%, what would you get? So what's the con of making this decision?
Or you're going to anger your distributors. I think that's one of the big cons. You're going to frustrate your distributors, and this isn't even allowed currently. If you're talking about the $10,000 penalty, I mean, this is not in our current contract. So we would be stepping out of bounds of our current contract. So really, this was just an exercise to see, like, you know, should we think about renegotiating our contract in the future? As far as I know, I don't know exactly what the penalty would be from our distributor to do this now, but it's definitely not allowed in our contract.
Then on any other pros and cons you guys ever figure out?
On mine, the one thing I noticed was significantly reduced numbers in clubs. And even though they're not making you a lot of money at this point, it's a bad idea to send young kids to other tournaments. So those are the same kids that are gonna go out and play golf, right? So if
That
you're
is
only
true.
looking at the short-term profit, you may be losing clients in the long term.
That's an excellent point. That is an excellent point. That is true.
Okay. Okay. Any other questions from you guys? No? Okay, just two brief comments. First, do you have a slide number? No, right? No. Okay, so for future presentation, I have slide numbers, so we can point to the, hey, can you go back to slide number 3? Okay. Second, I think you use the I two different places in your model. The subscript. The decision variables are X, Y, and the subscript I, right?
Yeah.
And the other place you used I to represent the percentage.
Yeah,
So
just
then-
I use on the slide. It's not in the model.
Okay, but in the slide two,
Yeah.
it's kind of like a
Two
little
different.
confusing.
Yeah.
Right, you need to use different
Yeah.
symbols to represent different things. Okay.
Another comment that I had was on your constraints. When you look at the third constraint, that's not necessary because that was not part of your decision variable to begin with. So you only need 3 constraints, not 4.
Which one, the ones that are zeros?
Yes.
Okay.
So it said, if you see in the,
Oh, yeah.
at the bottom of that, it said that was a redundant constraint because it was already taken care of, actually in 2 different places, but it was taken care of in the objective function formula because we just put $0 next to those. But yes, you're right, it was a redundant constraint. But we added it because it was a constraint.
Okay. Okay, good. Thank you.
Thanks.